Hello everyone. I'm going to attempt to take you through using half equations to balance a redox reaction today. I apologise for the quality of the video. This is my first attempt at doing this, and I'm going to attempt to do it all in one take, and therefore there may be a few pauses and things. But hopefully this will help you to go through one of the PowerPoints that we've set you on Moodle to have a look at. In order to do this, you are going to need to have a few things to hand. You're going to need the PowerPoint on Moodle, and you will want to be looking at a copy of slide 22, which we're going to talk about. We're going to talk about how to use that one. We are going to also need your rules from the cover of your blue redox booklet. Okay. This page of rules is your, let's hold it there, is your sort of Bible for this whole topic. Okay? So, let's get started. We are looking at a reaction. This is a reaction between iron 2+ and what we call the manganate ion. So, this Mn is manganese, it's a transition metal, and it's in the manganate ion. Bit of a recap from one of the previous topics. You are looking at an ionic equation. So this is the reaction where some of our ions are changing oxidation state. There would be some spectator ions involved, perhaps potassium, which is not going to change oxidation state, is a spectator, is not going to be in this equation. So looking at it, you should already be able to tell that it's not balanced for a few reasons. So I'm going to do that. I'm going to try and pause and give you a moment to think about things as we do these. You can always pause the video, of course, and rewind it, so I won't do that too much. We've got some oxygens here and none on the other side, so we need to work out how many of those there are. That's a reliable way of knowing it's not balanced. Another clue that it's not balanced, slightly less reliable in my experience, is that if you start to add up the charges on the left and right, that arrow is not very clear, is it? If you start to add up the charges on the left and right, you'd notice that the charges are different in total. So what we're going to need to do is look at how to balance this equation. Now this is a sort of big complex example of how these are done. So the PowerPoint takes you through some simpler ones. I thought we'd do a big one. I like this one. I like this one because it involves the manganate ion, which is a beautiful purple colour, and we meet it quite a lot. Okay, so we're mixing up some ions and this lovely purple manganate. So let's look at some oxidation states. We need to work out what's being reduced, what's being oxidized, and you can get that from the little list of rules in your blue booklet. Let's start with the ion. Well, rule 2, simple oxidation state. Simple ions, that must be +2, the same as its charge. That must be +3. Okay, so we'll do this simple ions first of all, +2 and +3. Now let's look at what's happening to the manganese. So I'm going to quickly show this again. If this doesn't make sense, you can rewind and look at this part again. We use rule 3 from the booklet to find what the manganese is. To help us with rule 3, I like to use a number line. That's how easy the maths of this part is. The manganate ion MnO4- has a negative charge. This tells me that I'm trying to get to -1. -1 is the target for this species. And I need to know where to start. Well, I can use rule 4 to find out where to start. Rule 4 tells me that oxygen is -2. There's a -2 on each oxygen. Okay, there's 4 oxygens, so those 4 oxygens are going to take me all the way down to -8. Down to -8. Okay, so I want to get from -8 to -1. What do I need to do? Well, I must be adding 7. Okay, so if that didn't make much sense, slow it down. Have a look at the previous PowerPoint as well. +7 on the manganese. And our last one, that's easy. That's 2. Okay, so we've got our oxidation states. Now we need to work out what was oxidized and what was reduced. So we can look at the changes. Iron's easy enough. +2 to +3. It has increased in oxidation state. On +1. So that has been oxidized. That means that the iron, when it started in 2+, has now, you can think of it as losing an electron. An electron that it had on its outer shell has moved away, one of them. So, +1 to go from 2 to 3. The manganese atom, this bit here, not the whole ion, +7 to +2 is -5. It's been reduced. So again, you can think of it as 5 new electrons around the manganese. That's a bit too simplistic, but 5 new electrons on the manganese gain some electrons. Loss and gain. Okay? Now, for obvious reasons, I'm going to actually have to remove some of that so that I can fit the rest on. But we know what was oxidized and reduced. So we are in a good place to do the next stage. So we're aiming to balance the equation. Now we know what's what, we can write 2 half equations for it. Redox equations come in halves, with 2 halves to them. So let's have a look at the oxidation half equation for that ion. Is my head going to be in the way? Yes, it is. So the oxidation, we've got Fe2+, and I'm going to do this in quite a specific way. Fe2+, and I'm going to leave big gaps as I write this. If I squash all this together, I'm going to find the next bit quite difficult. So I'm going to leave a gap either side of that. Going to gap Fe3+. Okay. There's gaps. Fe3+. Okay, so this is where I start to work my way down slide 22. 1. Balance the element. Well, the iron, the Fe is balanced in the top equation and in this half equation, so we can do that. Balance any oxygens with water. None of those. Balance any hydrogens with H+. None of those. So we're just going to skip straight to this bottom bit. Balance charge with electrons. We want to think about the electrons in this half equation. We decided we lost an electron. Okay, we lost an electron from the edge of the iron. Okay? That means that I've gone from having iron sitting with lots of electrons around it to having iron with fewer electrons and another electron that's floated away. Okay, so we had lots of electrons in one place, now we've got some still in the iron and one floating away here. That means that the product of this process, the right hand side of this half equation, has an electron involved. And again, leave gaps between those, you'll see why in a minute. That's a half equation for the oxidation of iron. Let's see if we can now move on to the half equation for the reduction of the manganese in the manganate ion. Let's see if I can get the titles done a bit better. Well, you get the